Alright, so this chapter is thermal properties. So first of all, you can see thermal expansion of solids, liquid and gases. Okay, so you know when you heat them up, they expand. Okay, so the first point, solids, liquid and gases expand when they are heated. So now we want to know the reasons. The reason is because atoms vibrate more. So this is more for solids. Okay, for liquid and gases, you should expect them to move faster, and this causes them to become further apart, taking up a greater volume. So that's why it expands. Okay, next point. Due to differences in molecular structures of the different states of matter, so they are trying to say that solid, liquid and gas have different molecular structure. You know, basically solids, they are orderly arranged, liquids, they are kind of close together, gas, they are further apart. Okay, so different structure, different molecular structures, and the expansion is at different extent also. So you can see expansion is greatest in gases. So greatest in gases basically because the gas molecules has the weakest chemical bonding, and intermediate or moderate in liquids. Moderate in liquids basically because liquids have moderate chemical bonding or chemical or intermolecular forces, and lowest in solid basically because it has the strongest intermolecular forces. Okay, so now we see the next point, applications and consequences of thermal expansion. Overhead cable have to be slack so that on cold days when they contract, they don't snap or detach. Okay, so the overhead cables are the one that we see maybe in front of the house or beside of the road. So you can see two poles, and then you can see the cables. Let's say this is the ground. Okay, you can see the cable is like hanging in this particular way, which is not is not stretched fully. So it's just like this. Okay, so of course the reason is so that on cold days the cable may contract, the cable will not break down. Okay, we don't want it to break down because of cold days. So second applications, you can see gaps have to be left in breach to allow for expansion. Okay, so gaps in breach. So for example, something like this, let's say this is a breach. Okay, so this is the okay, so should touch together. This is the side of the river, so they should have a small gap over there. Okay, a small gap here, and let's say this is the road, this is the bridge, and let's say here is the river, so this is the road again. So you should expect to have a small gap here as well as here, so that during daytime the bridge may expand. So the expansion of the bridge doesn't cause the road to be broken, or doesn't cause the bridge to have no space to expand and affect its structures. So we don't want that to happen, so that's why we leave gaps in the bridge. Okay, now the next application, you see the third one, bimetal thermostat. Okay, bimetal thermostat. First, when you see bimetal, so you need to know that they use two metals, as you can see here. The blue one is one type of metal, and then the gray color is another types of metal. So we have two types of metal put together, stick together in this particular way, and after that you see this particular part, they are not in contact. So if they are not in contact, the circuit is not function. Sorry.
Which gray color part is the other metal?
Sorry, what you say again?
You said one of the metal part is the blue one and also the grey one. So
yes, correct.
Which grey one is the metal?
It's the one that I am pointing now. This one. This is the other metal. So
okay.
The blue and the grey.
Two metals are together.
Yes, they stick together. So the two metals are together, where they stick together, and after that, you can see this particular part again. They are not touching with the contact here, meaning that this circuit is not functioning, or in other words, it has been turned off. Okay, so let's see what else they said here. When temperature gets too high, bimetal strip bend to make contact separate until temperature falls enough, then metal strip will become straight again and contact touch to maintain a steady temperature. So it seems like the word here and the pictures here is not that relevant. Okay, so I let you see a bimetal thermostat from the internet. Yeah, so let us look at the internet for more details on this. Okay, so I put it here. Bimetal thermostat. And look at the image. Okay, we can't see the structures clearly for this case. Bimetal thermostat diagram. Okay, this should be good enough. Okay, so when you look at this, first you can see there are two metals here. Okay, 1 and 2. Okay, so they are in contact when it is not hot. It is not hot, and we have electrical connection because here is touching. The circuit is closed. Okay, so the circuit is closed. The switch is closed, and when it is hot, then the two metals here, they bend at different rate, so making the whole structures to bend upwards, and then they are not touching each other, so the circuit open. So from here we get the idea. The circuit is closed, or the switch is closed when it is cold. The circuit or the switch is open when it is hot because of the different rates of expansion of the two metals here. So this is the idea. Okay, let's come back to the note. That's why when you see here again, bimetal thermostat, when temperature gets too high, so if you still remember the picture just now, get too high, it is separated. So bimetal strip bend to make contact separate. So remember that, that bend and separate. Okay, so try to recall back the picture just now. Okay, the picture just now, it is hot, then it bends, and then it is not touching the contact. So then metal strip will become straight again when the temperature falls, and because of that, they can touch each other, the contact touch, and then the circuit will continue to flow. The current is flowing, okay, in cold temperature. So from here,
When it's cold,
yeah,
when it's cold, when it's cold, it won't touch the contact, the bimetal strip.
when it is cold, they touch.
Oh,
Yeah, you see here.
so
When
when
the
it's
temperature
hot, also
fall,
it touches.
when the temperature is hot, they are not touching. You try to look at the picture again. Yeah, see, huh? When it is hot, the contact is not touching. So when it's cold, the contact is touching. Yeah, okay. So when it's hot, when it's cold. Okay, so when it's hot, as you can see, the heat will make it bend, then it's not touching. Okay, hot, bimetal strip bends, and then not touching, and then that means it is off. When it's cold, the bimetal strip is straightened, then the contact touch, so they touch, and then it's on. So basically it's like this. Okay, so you better look at the pictures from the browser instead of this one. Maybe you may misunderstand. Okay, so we look at this. This
Can I
yes.
go to the bathroom and just wash my face because I'm feeling sleepy?
Okay, sure.
Thank you.
Okay, now let's look at this point. For a fixed mass of gas at constant pressure, the volume is directly proportional to the Kelvin temperature. Okay, so what they say is something like this. You know, when I say directly proportional, you should think of the graph where the volume versus the temperature in Kelvin, directly proportional. That means the graph is a straight line from origin. So we should have a graph in this particular way. Okay, so this should be kind of reasonable, because imagine that if the temperature is higher, the gas expands, then it has a greater volume, okay, because of the expansion of the gas. Now we look at the next part, measurements of temperature. Okay, so you want to measure temperature, you may think of thermometer, okay, but we have different kind of thermometer. Now let's see how it works. The first point, a physical properties that varies with temperature may be used for measurements of temperature. Okay, so what physical properties that varies with temperature? So for example, volume. You know, volume varies with temperatures. So when the temperature increase, the volume increase. So this is a physical properties that varies. Okay, so of course the volume that increase with temperature, we have to make sure that we can detect it. Okay, maybe we can see it by eyes, or maybe we can measure it. What else? Other physical properties that varies with temperature, for example, like the resistance. The resistance change with temperature. Okay, resistance. So of course we will discuss this in details afterwards. So we look at the second point, liquid in glass thermometer. So that means we put, for example, mercury or alcohol in the glass, and then it expands when the temperature is hot, and then we can see the alcohol or the mercury go further, and then we can read the corresponding temperature which has been set up. Okay, so that is liquid in glass thermometer. So of course this thermometer is kind of famous. I think we use it also. Okay, so in clinic as well as in laboratory. Okay, so we look at the structures of the thermometer. So you can see mercury alcohol reservoir over here. So that means this is the place where they put or they store the mercury or the alcohol. And then we call this part the glass bulb. And then we have the glass stem. Then in the middle you have the thread where the mercury or the alcohol will come out when it is hot. Okay, so we have capillary. Capillary is the small glass tube in the middle. Okay, so as temperature rises or falls, the liquid, so the liquid here we can use mercury or alcohol. Okay, so they will expand when it's hot, they will contract when it's cold, and the amount of expansion can be matched to temperature on a scale. Okay, so that means what? Try to imagine you put your thermometer in icy water, so the temperature is expected to be 0 degrees Celsius, and you see where is the thread. Okay, let's say the thread is here, then you mark here to be 0 degrees Celsius, for example. Then now you put this thermometer in a boiling water. So you should expect in boiling water the temperature is 100 degrees Celsius. So you check the thread. The thread means the mercury in the capillary. You check that. So let's say it expands all the way until here, and then you mark down this point and you label it at 100 degrees Celsius. And then after that you separate the part in between by 100 parts. So this is how we set up the scale, and we call this calibration. You see the words calibrating is used, so that means we try to set up the scale. Okay, now let's look at the next part. Thermistor thermometer. So this is the second types of thermometer. Just now the first type is liquid in glass thermometer. This is the second type, thermistor thermometer. Okay, so the word thermistor, therm means temperature or heat. The mister at the back you should link to the resistor. Okay, so it's the resistor that affected by heat. Okay, affected by heat. So let's see the information here. The probe contains a thermistor. So I put a thermistor here. So thermistor is basically an electronic component, so which has different resistance and different temperature. So the thermistor is a material that becomes a better electrical conductor when the temperature rises. So it's a semiconductor. Semiconductors have these properties. If you still remember chemistry, right? Semiconductor is a material that has low resistance when the temperature increases. So remember that, semiconductor, temperature increase, resistance drop. And compared to metal, you need to know that it is the other way around. When temperature increase, resistance increases. But semiconductor is just the other way around. Okay, so that's why we use it as thermistor. Okay, we use it as thermistor thermometer. So you put a semiconductor here, and we call this semiconductor thermistor. When the temperature increase, resistance drops, higher current flows because of lower resistance, and higher currents which flows is changed into higher reading in temperature. Of course they are doing the setting on the other side, so we are able to just read the reading straight away. Okay, so actually The idea is when the temperature increase, the resistance drop. When the resistance drop, there are higher current which flow through the circuit, and because of that, the meter will have a higher reading, but they don't show you what current is flowing. They don't show you how many ampere, they show you how many degrees Celsius. That means they have do some adjustment there to change the current into temperature. Maybe they have done some formula or what. Okay, so and what you see is just the temperature, not the current. Okay, now we see the next one. Thermocouple thermometer. Thermocouple, so the couple means two. Okay, two. So two metals. Again, two metals. Okay, so we have iron as the first type of metal, and then we have copper as the second types of metal. So the iron and the copper are joining up at 2 points. One point on the left, hot junction, another point on the right, cold junction. Okay, so of course hot junction is where we put this into something hot, for example boiling water, and then we put this into something cold, for example icy water, so where the ice is melting. So you should expect it to be 0 degrees Celsius. So imagine if you do something like that, 0 degrees Celsius on this side, 100 degrees Celsius on this side. So the temperature difference should be 100 degrees Celsius. So the voltmeter should show certain voltage reading. Because of the different temperature. Yes?
You mentioned just now the hot junction is, examples are yeast.
Example is, sorry, can you say it again?
Can you repeat, tell me again, what is the example for hot junction?
Oh, hot junction, okay. I write down at the same time. So hot junctions, example, you put in boiling water. Put in boiling water, and you should expect it to be 100 degrees Celsius. Then after that, cold junctions, for example, you put in ice water, then you should expect it to be 0 degrees Celsius. The melting process is happening, so 0 degrees Celsius. And let's say for this situation, when you put hot junction in boiling water, you put cold junction in ice water, the voltmeter shows 5.0 volt. Example only. Okay, so I just want you to imagine only 5.0 volt. Okay, then that means when the difference in temperature is 100 degrees Celsius, it shows 5.0 volt. And because of that, we can just break down the 5.0 volt to 100 parts. Try to imagine. I'm trying to explain to you how it works. 100 parts. Yes.
It's something like measuring the EMF.
Yes, the EMF. The voltmeter measure the EMF or the voltage or the potential difference. Yeah. Okay. So because the temperature difference is 100 degrees Celsius, so that's why we break down the 5.0 volt to 100 parts. Okay, 100 parts, something like this. Imagine 5.0 volt divided by 100 parts. Then of course we can say that this is going to be 0.05 0.05 volt for 1 degree Celsius. It's something like this, so because of that, then let's say now you want to measure body temperature. You want to measure body temperature or temperature of whatever lah, okay? So you take out the hot junction from the boiling water, but you put in, let's say you want to measure, we don't want body temperature lah, okay? Let's say you want to measure something that you don't know what temperature is that. So let's say you want to measure the temperature of a particular food, which is Coke. Okay, then you put this hot junction in that food, and the voltmeter shows, let's say the voltmeter shows 2.8 volt, 2.8 volt, and then you just use back the same idea to find out the temperature. So it's something like this. As you can see, if 100 degrees Celsius is 5 volt, so then 1 degree Celsius is 0.05 volt. So now what they say is, what temperature is it when it is 2.8 volt? 2.8 volt lah. So you can just do the calculation or use ratio to find the temperature. Okay, to find the temperature. So basically you take x divided by 1, 2.8 divided by 0.05. So we take this divided by this, and hence here take this divided by this. Then you will get the temperature of the substance that you are measuring, which means for our case is the temperature of the food that we want to know is temperature. Okay, so we use 2.8 divided by 0.05. So let's say we get 56. So showing that the food is 56 degrees Celsius. Okay, so something like that. Example. Okay, just a rough idea on how it works. Okay, why we need cold and hot junction. So it's because of something like that. Now, the probe contains two different metals, joined metals to form two junctions. One is called hot junctions, another one is cold junction. The temperature difference causes a tiny voltage, which makes a current flow. Okay, so when the temperature is not the same, 100 and 0, so there is a voltage, there is a potential difference, and because of a potential difference, the current flow, and that's why it shows reading here. A greater temperature difference give a greater current, okay, so for example, you see if the temperature difference is 100 degrees Celsius, it shows 5 volt. When the temperature difference is smaller, 56 degrees Celsius, I say smaller because cold junction is still in ice water, hot junction is in the food of 56 degrees Celsius, so the difference is smaller, and then the voltage is 2.8, so it's smaller voltage. Okay, so of course this is the example where I assume that it is linearly related, then we can use this way to do it. Okay, so it's just example. Now let's move on. A greater temperature difference give a greater current. Okay, so thermocouple thermometers are used for high temperature which change rapidly and have a large range, -200 degrees Celsius to 1100 degrees Celsius. So it has two advantages here. It is for high temperature. You see, it can measure up to this temperature, it's kind of high, and it responds quickly. That's why we can use it to measure temperature which change rapidly. Okay, temperature that change rapidly. So it's hot in a sudden and cold in a sudden. You can quickly detect it if you are using thermometer, thermocouple. But you can't quickly detect it if you are using liquid in glass thermometer. We can't quickly detect it. If you still remember, you visit clinic and old time, not nowadays. Nowadays they use digital thermometers. Old time, if you visit clinics, they use liquid in glass thermometer, put under your armpit and measure the temperature. It takes time. Okay, so we need to wait for the mercury to expand, so it takes time. So we can't detect change in temperature quickly if you are using this. But thermocouple thermometer can do that. Okay, so we look at the next point, fixed points. Fixed points are definite temperature at which something happens and are used to calibrate a thermometer. So the fixed point that we normally talk about are the melting and boiling points of water. So that's why I'm using this. Put in ice water. This is the melting of ice, 0 degrees Celsius is a fixed point. The other fixed point that we normally use is the boiling of water. So when the water boils, the temperature is 100 degrees Celsius. So we call this fixed points. So when we talk about fixed point, make sure you know that it is the melting of ice and the boiling of water. Okay, so that are the fixed point that we normally use because water is easily available and its melting point and boiling point is well known. Okay, now let's see the next one. The next one, calibrating a thermometer. So calibrating means you have to set up the scale of a thermometer. So you have to place the thermometer in melting ice. This is 0 degrees Celsius. So this is what I explained just now. Something like this. You put this thermometer in melting ice, so then the mercury will reach this particular level. Then you mark this point at 0 degrees Celsius. Then you put the thermometer in boiling water, then the mercury expand to this point, and then you mark this point at 100 degrees Celsius. Then you divide them into 100 parts, and then you can set up the scale. That is called calibration of a thermometer. Okay, now let's continue. Sensitivity. Sensitivity is the change in length or volume per degree. So change in length. So if the thermometer is sensitive, let's say for example this thermometer, if this thermometer you want to make it more sensitive, so the way is you have to make sure it is like this. You use the thinner capillary, a less dense liquid, or a bigger bulb. Okay, these are the three ways to make it more sensitive. So when it's more sensitive, basically when the temperature change by 1 degree Celsius, the mercury will move more. Okay, the mercury or the alcohol will move for a longer distance. So how to make it move for a longer distance? You have to put thinner capillary, so that when it expands, it will move for a greater distance. Or you use a less dense liquid, so that when it expands, it is less dense and it moves for a greater distance. Or you use a bigger bulb. Bigger bulb means here, that means there are more mercury or alcohol stored over here. And then when you heat it up, then it expands and it go for a further distance. So that is how we increase the sensitivity. Basically it means when the expansion of liquid happens, it moves for a greater length, or when it expands to make a bigger change in the volume. Okay, so that is the idea of sensitivity. Range is the upper and lower fixed point. Okay, range of the thermometer, for example, this is the range of the thermometer. So the negative 200 degrees Celsius to the 1100 degrees Celsius. So this is the range of the thermometer. Then we have the linearity. Linearity is related to straight lines, of course. So you see, change the distance between intervals. Okay, change the distance between intervals. Not that clear when you see this point alone. Change the distance between intervals. Okay, so I will give you more examples, but let us go through this point first, then I will explain more on this. Responsiveness. How long it takes for the thermometer to react to a change in temperature. So for example, like what I mentioned just now, Thermocouple Thermometer, fast response. So it is used for temperature that change rapidly because fast response. Liquid in glass, slow response. Okay, so we can't use it for rapid change in temperature. So cannot. Okay, now linearity. Linearity. So we want to understand more on linearity. Okay, so first, linearity is about straight line. It's about straight line. Okay, so let's say I know volume versus temperature is a straight line. It's a straight line. So volume, temperature in Kelvin, we have a straight line graph. So a straight line graph means linear graph. Okay, so the change in distance from 0 to, let's say, to 50 Kelvin. So it changed by, let's say for example, it changed by 100. Then from 50 to 100, you should expect the same change to be 200 then. So that is the idea of linearity. Change the distance between intervals. So from this interval to this interval, the change is 100. So if you have the same interval of 50 to 100, the change is 50. Then we should expect the change here to be 100. So that is the idea of linearity. So it is proportional in other words. Okay. Now let's move on. Next page. Okay. So on this page you have the starting of something basic, melting. This is when a solid turns into a liquid. Temperature increases, thus kinetic energy in solid increases. And particles vibrate more rapidly, but there is no increase in temperature of the substance when melting, because thermal energy supply is instead being used to break bonds between particles of the solid, thus making it into a liquid. So when you look at this second point, right? First point, nothing. First point is kind of basic. Melting is solid, turns into liquid. But second point that give us that told us something important. Okay, so when you heat up the substance, the heat energy is used to increase kinetic energy. Okay, so that is one way to use the heat energy. Kinetic energy in solid increase. This is one way to use the heat energy supplied. Okay, and the second way to use the heat energy supplied to the substance is to break the bond between particles. This is the second way. Okay, so if you use the energy to increase the kinetic energy in solids, and it will come along with the temperature increase. It's something like this. When you are heating up a substance, the substance may use the energy in two different ways. The first way is increase the kinetic energy of the particles. If this happens, temperature will increase. That is the effect. If the substance use the energy to break the bond, then the temperature remain the same. Okay, so there are two ways to use the thermal energy supplied, and it has different effect. Okay, so during melting, they use the energy to break the bond, so that's why the temperature remain the same. Okay, before melting, you are heating up the solid to the melting point, so that is where they use the energy to increase the kinetic energy. So that's why temperature increase up to melting point. Then it becomes the same because they use the energy in different way to break the bond. Okay, now next point. Boiling point is the temperature at which a substance boils. Okay, so this is basic. Okay, I don't know why they say boiling points at this part. So boiling point should be under this part, right? Okay, should be under boiling. So let's see boiling.
So,
Yes.
so there are two ways on how melting affects a liquid.
Melting affect the liquid.
To break the bond, and which is to break the bond, and also by increasing the kinetic energy.
We should say it in this way. There are two ways on how thermal energy is used by the particles. Yeah, should be this way to be more accurate. We may say it in this way. Yeah, to increase the kinetic energy or to break the bond. So is that okay?
Yes.
Okay. Now let's continue. Temperature increases, thus kinetic energy in liquid increases. So it's this concept. The liquid use the thermal energy to increase the kinetic energy of the liquid particles, and because of that, the temperature increase. Okay, so the temperature increase until boiling point. Now they use the thermal energy supplied to break the bond. That's why at boiling point, the temperatures remain the same, because they use the thermal energy to break the bond instead of increasing the kinetic energy. So that's why there is no increase in temperature at that time during melting. Okay, so next point. Melting point is the temperature at which a substance melts. The difference between boiling and evaporation is that boiling happens at 100 degrees Celsius for water, but evaporation can happen at any temperature. So as long as the water is exposed to the surrounding, then it evaporates. Okay, so you see the point here. Boiling occurs at a fixed temperature and throughout the liquid. So if you see boiling of water, right, so it happens, the bubbles of air come up even at the bottom of the water, not just the surface. Okay, it's everywhere of the liquid. But evaporation occurs at any temperature and only on the surface. Only on the surface. Okay, so of course boiling and evaporations, we have different concept. Okay, although they have a similarity where both involve the change of liquids into gas, but there is a difference between boiling and evaporation. Boiling is where they use the thermal energy to break the bonds, but evaporation is where molecules with higher kinetic energy escape from the surface. Okay, so different, huh?